Hello, everyone. Hello and good morning. I am Myro. I'm Avance Metering's marketing manager, and will be your co-host today for this webinar, together, of course, with our David Svensson, the man of the hour, who will be presenting this webinar for us. I could not start this webinar if not by thanking David for the time and effort he has put into this, for the availability to educate us on harmonics. So thanks, David. It does not go unnoticed. It's deeply appreciated. Thank you.
Thank you.
Yeah. On our next slide, please, David. We'll be seeing the agenda for today. We'll start off with a very brief, very short introduction on the both companies here, Avance Metering and Göterborg Energi. And then David will take the floor, teaching us about harmonics, on how to detect it. He will also be showing us not only one, but three case studies, real life scenario case studies on how to identify harmonics, solutions and mitigation strategies. And then at the end, we'll have a Q&A session, right? Just note that webcams and microphones are off throughout the presentation, but the chat's open. So you don't need to wait until the Q&A session to actually type in your question, right? Once we get into Q&A part, we'll do our best to answer them. Next slide, David, please. Just as a very short, brief introduction, Avance Metering is a 25-year-old company coming out of Östersund, Sweden. We develop flexible, interoperable, and efficient software that collects, stores consumption and production data from electricity, district heating and cooling, gas, and water meters. We are completely multi-communication, multi-utility, and meter agnostic, meaning we can work with pretty much any smart meter you have, and we'll adapt and make it work. By using our solutions, you can simplify, automate your business's process, as well as optimize the energy distribution. We currently offer 3 software solutions. The first one that you see over there is Collection Manager, the software that you'll be seeing a lot today, as David will be showing very nice screenshots of our software detecting harmonics. Second is MDM, and then third, Vision. You can find us at avancemetering.com on our own, or on our linking, Avance Metering. Rest assured, after this presentation, you'll be receiving this whole slide deck with all the possible links that you may need. So you'll be able to reach us anytime you want. I'll give the floor now to David, who will begin this webinar for real. Yeah, go ahead, David. The floor is all yours.
Thanks, Mario. Well, Göterborg Energi, it's a grid company in Gothenburg area with about 275,000 electric meters. And we began in using power quality data in 2014. Back then, we used momentary readings from the meters with voltage and current. A few meters showed odd behavior during the investigation. We saw that there were harmonic content present using a power quality instrument. The old meter showed us a hidden potential in the power quality data. So therefore, the ambition was high when we launched the tender for new meters in 2019. And since the contract was signed, we have been working with the power quality data from the new meters. Their ability to measure harmonic content has proven to be successful, but it took a lot of work to get us where we are now. You don't need a bachelor degree to use harmonic readings from the meters. You just need basic knowledge of what harmonic is and what it does to a power system. Harmonics is the presence of unwanted frequency components. As you can see in the picture, it will affect the waveform for the voltage and the current. When harmonic is present, it can significantly impact the performance and the reliability of a power system. To find a disordered wave, you need to use the total harmonic distortion, THDU, from an electric meter. It considers all harmonics present that the meter can measure and calculate, not measure, but calculate. THDU will show the deviation in the voltage, and THDI will show the deviation in the current. We will focus on deviation in the voltage today. It's what most new meters can register. Harmonic components can also be measured individually, and we display each harmonic component as a percentage of the fundamental frequency. Individual harmonics can help revealing the source, as different equipment might have a problem with some specific frequencies. One equipment can give a fingerprint that might show up in other locations in the grid. There are several possible causes of harmonics in a power system, and here you can see some examples. We will stumble on some of these, and I will show some examples later in the presentation. Power quality data will give you valuable insights into these problems, and they're really able to track and understand them. There are also several possible impacts when harmonics occur in the grid. These are just examples that will give you an idea what could happen. If you don't measure the harmonic level, it's difficult to find the root cause if and when some equipment break down in the grid. To start investigating, you need to monitor the THD levels over time. You need to compare it with THD with other values from the meter, like the voltage and other values from other meters in the neighborhood. In this example, a poor connection creates an arc which will impact the THD voltage. Harmonics from electric equipment will affect the other customers in the grid. Comparing values from customer A and customer B will show the source of the voltage harmonics. The energy pattern will reveal customer B when THU and energy align. They are using the specific equipment that are causing problems for the grid. As you can see, it's long above 8% as the power quality standard. Imagine a customer complain about expensive equipment failures, only to discover that it was their own charging station polluting the surrounding grid with harmonic distortion. By analyzing the energy consumption patterns and voltage harmonics, we could pinpoint the source. But as we all know, these filters can degrade over time, allowing the harmonics to resurface. Following measurements over time will give you valuable insights about actions taken by the customer. In a huge grid area, our meters detected alarming events, total harmonic distortion levels exceeding 8% threshold. While one customer appears to be the primary source at the medium voltage grid, and other equipment under other substations creating a harmonic hotspot. As you can see, it's spreading over a huge area, over lots of substations, but just a few of them are going over over the 8% threshold. Some substations are below. And just in like case one, the harmonic patterns are proving elusive, making it a true power quality puzzle to find out what's going on. And when the industrial customer was moved during maintenance, the harmonic followed him over to the new transformer. And in the values, you could see what happened when we moved the industrial customer. Picture this: a substation with 3 transformers running hot despite a minimal customer load. The culprit: excessive third current harmonic. Multiple customers exhibit this harmonic signature, making it even more complex. We are still working on this case to figure out the root cause, but I have some idea where the harmonics come from. These 3 cases I've shown you illustrate the critical importance of understanding and detecting and addressing customer-generated harmonics. If you want to use THD voltage data from your electric meters, these steps can be helpful. Our approach is that we don't collect data from all the electric meters, but they will notify us when a limit is reached, and then we can change the meter's configuration to track THD data over time from specific meters. So step 1 is to retrieve data, and it's good to have the same resolution as the energy that you have on your meters. And step 2 is to understand all possible situations where you get high THD using visualization in a map with grid topology, visualizing data over time, and then visit these meters with a power quality instrument to get a more exact reading. The most important thing is to document all your findings. So you could find and go and look after your different situations. It's much more easier to if you have a document to go back to. Yes, that's what my 3 cases.
All right. Thanks, David. Thanks a lot. That was a very elusive on what harmonics are, at least for me, because I didn't know much about harmonics. So thanks. I invite everyone now that may have a question. Feel free to type in on the chat if you do have one. Can you see this, David, or you want me to read it to you?
Just read it.
Okay. How are you able to diagnose whether harmonics are generated upstream or downstream?
That's because we measure. We have measured different locations, and let's see. It's a lot about knowing the topology of the grid, and if you move the source, then the harmonics will follow the source. That's why I knew it's from them.
All right. Do you
Unless
analyze?
it's quite difficult to find the source.
We have a new question here. Do you analyze THD events from the meters in the grid topology context to select the meters from which to start collecting THD time series data? Or you collecting THD from all residential meters?
We collect just the events, and then we change the configuration on the meters to collect the data. And in the future, we will have a connection with the topology. Now I have to investigate and just figure things out. And build up a document with all the data and graphs to just figure things out. But in the future, we will connect the events with the grid topology.
Awesome.
Yes.
Yeah, there's a new question. Is high THD typically found only at the source of the distortion, or is it happening at many meters around the source?
Well, if it's something that spreads over several substations, you will get high readings from all the meters. So you will get this case was it? Let's see. I'll go back to this case, for example, gives a lot of events from all the meters that will go up over 8%. And that's a lot of meters. So this one has been really tricky to figure out where the source is, because it doesn't give a pattern that's easy. And the industrial customer has a high voltage meter, and then you have another resolution there. So you just have to build up a case and just gather all the data from all the meters and do some extra power quality instrument readings to figure things out. In the future, I have to do some more intelligent, automatic, something that goes more automatic. It gives you an idea of what's happening. But right now, it's like the beginning, and I don't have all the answers. I just like to investigate and to find the source. And if someone tells me it's really hard, and then I just try even harder.
Great. There's a long question here. Let me try to read it for you. Have you seen even harmonics, second and fourth, anomaly, or high amplitude signatures during high solar activity from your long-term measurements? Can be caused by half-cycle saturation of transformer due to GIC. Is it interesting to take a look, if not notice? And he's thanking you for your presentation.
Okay, for that one, I might need to read the question.
Sure. Should you click on the chat?
Yes, let's see. Yeah, that's a really good question. But the meters that we have today do not show even harmonics. And that's a pity. So we can only work with the ones like the third, fifth, and seventh, and 11th individual harmonics, but they do measure or just calculate up to the 40th, the individual harmonic.
Next question, David. I'm hoping that you're seeing this because it's also a long one. Yeah. What is your criteria to select which meters to start collecting THD time series data? Can the meters also collect time series data of an individual harmonics, third and fifth, or do you need special equipment for that?
Good question. I usually look at the events from the meter, and then try to figure out what could cause harmonics, and then I usually change the configuration on, like, if someone has solar panels or if they have a lot of consumption. It's usually where I start changing the configuration. And the individual harmonics is not available in our system yet, but they are at the meter's location. So if you go out to a meter, you can retrieve the individual third, fifth, the let's see, the fifth, seventh, and 11th harmonic. Yeah, so that is all. That is to come. Individual harmonics. Yes.
So there's a new question here that is actually my question as well. Is it some typical customer equipment that you'll find this, or are there some regulars?
Well, chargers seem to be something that's frequently seen in the grid with harmonics, and I think that I have a hunch that it would be customers with solar panels, but I've also seen that the same brand of let's see, the going from DC to AC, the thing transforming AC to DC, that the same brand could be without transforming harmonics, and so I think it could be other things that causes, like if you have some if you install the solar panels in the wrong way, maybe, or if you have some other equipment attached to the solar panel to get a greater amount of energy and more efficient, then that could be a cause of harmonics too. So I will look into this the more that the longer it goes, because it's not totally it's not a thing I work with all the time, but from time to time I look into the problem, and going out on the fields, it's very time consuming working with harmonics, but it's fun.
I have a question here, David, that it's not on the chat, and it's on the Q&A thing. It says, are you profiling THD on a regular interval on all meters, or just listen to the events and then start selectively to read and target meters?
I listen to the events, and then change some configurations in the area.
Regarding the last question on if there are any regulars, and you answered chargers, right?
Yeah.
Are EV chargers a cause? Do you happen to find this, that if EV chargers cause these eruptions?
Probably not all of them, but there are probably some charger that's causing the problem. And today customers are really happy that we inform them on the issue, because then the vendor has to address the problem. Probably this equipment is probably tested with maybe one charger going, and then when they maybe use the maximum amount of charges, and there's an issue.
All right. So no question here. Can you please let me know the typical specification of the meter used by you, specifically the sampling rate?
Which one is?
It's the one question asked at 1023.
29. Yes. The meter. I don't have the sampling rate in my head, but I probably will. It's probably possible to find it later. So if you could just type that one question down, I can get back to him.
Yeah. We do have more comments here, but they're not a question. Okay, just got one. What kind of customer meter supply do you have in your grid?
Let's see. Yes, we use Camstrup meters today. And we have also other brands. And the idea in the future is to collect more THD values also from the high voltage meters to get in the same resolution as the other ones. That's a really good idea, but it takes some time to get there.
All right. We have 2 more minutes to go. Any more questions? I do have one here. Again, are we talking residential wall boxes for the chargers or the big charging stations, for example, on a supermarket parking?
It's the big ones that's causing a problem. I haven't looked into the small ones yet, but I think it's more of the amount of the power that is used that it will cause a problem.
And David, would you say cheap electronics would cause a lot of harmonics?
Not sure. I haven't looked into those. It's easy to look into those like bigger problems at first, and then you have to work your way down. And soon we will have changes all the meters to the next generation, and then we have to just eliminate the harmonics in the grid. And we'll probably find more stuff when we later on.
All right, and there's a very specific question here. Do I understand correctly that you have looked at the LV network before the MV/HV network? Why was that?
That's because we changed the meters and we saw a lot of things going on in using the harmonic readings. And then we looked into what we could get from the high voltage meters, and we could see the levels there too. So, yeah.
All right. Well, we are wrapping up here. Some seconds left. Again, I'd like to thank David for the time and just the attention given to us throughout this whole preparation and this webinar. I'd like to thank everyone that joining. Remind you all that you will be receiving this recording as well as this slide deck. If you do want to get in touch with us, that will be all the links that you may need. Yeah, I hope you have enjoyed as much as I did. And again, thanks, David.
Thank you for listening.